This is the graph of our standard curve of caffeine concentration, and then the table below shows the concentration of standard in 2, 4, 6, 8 and 10 ppm, as well as the detected peak area of each concentration. For our sample, the peak area was 3615H, which fall within the range of 2 ppm to 4 ppm. So how do we calculate the exact value of the concentration of caffeine? Is we use the equation here and substitute the peak area y into the equation. So y equals to 36158, and then when you sub, you find out that x is 3.32 ppm. So 3.32 ppm means that it is 3.32 milligram per kg. When you change it to 100 gram, it shows that it is 0.332 milligram per 100 gram. However, our sample was diluted 100 times. Therefore, 0.332 milligram has to be times 100 to get 33.2 milligram per 100 gram. To the results obtained, the caffeine concentration obtained from the sample was 33.2 ppm. This shows that the caffeine content is 3 times higher than the caffeine content on the food labeling. According to USDA, a typical black tea has 20 mg of caffeine in 100 gram. The composition of the tea varies with the type of processing, the leaf's age, the species, the origin, as well as the climate. Since every batch of tea leaves may vary from one another, hence it's possible that the caffeine content is not constant for all batches. Also, Chloe mentioned that tea stored for 6 months contain more caffeine than the freshly manufactured product. Moreover, the caffeine content of teas is also influenced by seasonal, genetic, agronomic, and cultural factors.
Why reverse Hplc is used for the determination of caffeine is because reverse phase Hplc is actually one of the most widely used separation mode in modern Hplc, which is around 70%. In reverse phase Hplc, the mobile phase, which is methanol to water, is polar, while the stationary phase is the reverse phase C18 column. Solutes that are retained are due to hydrophobic interactions with non-polar stationary phase and are eluted in order of increasing hydrophobicity, or in other words, decreasing polarity. According to a study done by Zhou, Chen and Deng, use of this reverse Hplc system permits a fast and easy separation of caffeine from other substances such as tannic acid, caffeic acid, and sucrose found in these beverages. From the resulting chromatograms, measurements of retention time and peak areas can also be made. Furthermore, why do we need to plot standard curve to get equation? This is because standard curve provides a reference to determine unknown concentration. Thus, amount chosen of standards need to span the range of concentrations expected to be found in the unknown sample concentration. Standard curve for peak area against concentration of the caffeine standards can then be employed to determine the concentration of caffeine in the black tea. Moreover, 276 nanometer was chosen for the UV detector because wavelength set at this is due to the color of the solution was colorless and fall in the range which is below 400 nanometer. Also, the purpose of adjusting the mobile phase to pH 3.5 was because pH plays a crucial role in determining retention and selectivity, and also in controlling the reproducibility. Low pH has the advantage of creating an environment in which peak tailing is minimized and method ruggedness is maximized. For this reason, operating at low pH is recommended.
What are the precautionary steps for Hplc? So according to Sharma, the sample must be fully soluble in the mobile phase when dissolving. If not, the precipitate may take place at the top of the column, which make it unable to flow through the column, and this will give a false result. So furthermore, we also have to filter the mobile phase. By filtering the mobile phase, the analytes can reduce their risk capable of plugging the sinker and column fluids, and which causing contamination, damaging pump valves, blocking capillaries, and also which contributes to poor peak performance, and also extra peaks and excessive chromatographic noise. So this mobile phase filtration is performed prior to placing the solvent into the solvent reservoir. So also, HPLC mobile phase should be prepared fresh before analysis, as long storage can lead to microbial growth and other suspension which can lead to complications in the flow during analysis. In case such suspensions are seen in the mobile phase, it should be discarded and then prepared again freshly. So last but not least, remember to wash your column and pump it with water to prevent deposition of solid crystalline deposits, because they will cause column blockages, which leads to faster wear of the pump components.
The concentration of black tea from the result using HPLC is 33.2 mg in 100 gram. The hypothesis is rejected. The concentration content is not the same as the claim on the nutrition labeling on the black tea. Therefore, the caffeine content on the pack was not accurately presented. This is due to composition of tea varies with the type of the processing, leaf age, species, origin, and climate. Since every batch of the black tea leaf varies from another, so it is possible that the caffeine content is not constant for all batches. Also, tea stored for 6 months contain more caffeine than the freshly manufactured product. Moreover, the caffeine content of the tea is also influenced by seasonal, genetic, agronomic, and cultural factors.